Hello Year 11 and welcome back to our second video for the fourth topic here. We were interpreting graphs in our last video and now we are looking at misleading graphs, right? Graphs that might suggest the wrong interpretation, okay? Now that can be done deliberately or accidentally, right? Or carelessly. Sometimes, publishers or various organizations might want you to think something that the data is saying something that it doesn't really say. It might try to exaggerate something. One of the ways we can do this is this thing called a truncated axis, where you don't start your vertical axis at 0, right? That's going to tend to exaggerate the variation within the data. Right? That might be a reasonable thing to do, as long as you make it clear that the axis doesn't start at 0. You can see in this silly graph here, they haven't truncated it. They've gone from 0 to 100%, but they have bent the grid lines so that really, this would suggest that each one of these data points is somewhere between 10 and 20%, right? Now, at a glance, it looks like it's growing a lot. But what it's really sort of suggesting is that the shape of that line has been manipulated by this ridiculous bending of the grid lines. It is a joke. But here we go. Here are some other misleading graphs. Now, this is all the same data, and yet those three graphs look fairly different. What is wrong with them, right? You can see here's the actual data, and as good as that is, having a graph, can make it a bit easier to interpret what's going on there, to see a trend with a line graph. Yep. Now, what's incorrect and misleading about each graph? First one here. See, this starts with 10. Where's my 0? Right? So, graph A, vertical axis is truncated. Truncated means chopped off. At 10. Now, what's going on with B? Well, not only is chopped off, right? If that was 0, well, it might be. This here represents 4, right? From 16 to 20. Then I've got 10, then 2, and 3. My vertical axis, or my vertical scale, is irregular. Right? That's very misleading. Finally, let's have a look at graph C. What's wrong with this? Well, 10, 20, 30, 40, that looks pretty good to me. We're okay across here. We might say, and actually I think if we look in the book, the answer they suggest is that they're saying the horizontal axis has been compressed, which exaggerates the gradient, if you like, how steep the line is. Horizontal axis is compressed. But you know what? It's still regular, so I don't have a huge problem with C. We can't compare it as easily to the others, but you're not going to compare it to a misleading graph anyway. Now we need to draw the correct graph for this data. So my top row is what we would call the independent axis, and that'll go on the horizontal axis. So I want to go from, I suppose, from 0 to 5. Right, I'm going to do this here. I'm going to go right in the corner. Now, I think if I go for, I reckon I can fit 4 in there. I'm going to call that 1. You should use a ruler and a pencil. Doesn't work very well on a screen like this. 3, 4, 5. Look at that. Just neatly fits. Right, and right, I'll do my very best here. Right, and axes need to be labelled. So that is the week. My vertical axis, I need to go up to 35. What have I got there? I think if 2, 4. I might make every 4 squares. Yeah, maybe that'll work. Maybe that could be 10, 20. 30, 35. Oops. Righto. Nice, consistent axis. Graph paper is called graph paper for a reason. 5, 10, 15, 20, 25, 30, 35. Righto, now we've got these things. 1 and 16 is my first point here. So across 1 up to, right, so looking at this scale here now, each of those is 5, so it's 2.5. So I need to go up 1, which will be just less than halfway. Whoops, that's not what I wanted to happen. Right, so it's going to be about there. Use your ruler. 116, 221, cross 2 up to 21. Again, that goes about there. Then we've got 3 and 27. 3 and 25. That'll be 27.5, so just under there. 3 and 27. 4 and 30. That's a nice easy one. And finally, 5 and 35. 5 here, 35 here, right in the corner. Right, and I'm not going to put a curve through these. I'm going to join them up. Now, we could say at week 0, I sold no computers. Oh, wait, I forgot to label this axis. Number of computers sold. I don't think that it's really appropriate to bring that down to 0 because, well, that sort of suggests I wasn't working. I didn't sell any computers. I don't like that. I would prefer to start where our data starts, not to assume that I've got a 0, 0. That's not my data set. It's not really implicit in it either. So I think that is a reasonable graph. We have nice consistent axes that are labelled with a regular scale. I could have a title for this graph, but you know, I don't. Graphs should have a title. Axes should generally have arrows on the end of them like that, and units and whatever else, but that's not too bad. Okay, so that is constructing graphs, or they are misleading graphs, I'm sorry. They are misleading graphs, and you can see that that doesn't look a lot like any of the others. It sort of looks a bit like this, but flatter because I've got a different sort of scale. Yeah, but I wouldn't go back to the 0. Anyway, any questions? Save them up, ask me in class. I'll see you there.